Use an inverse function. Peggy rents a car for the day. The total cost C of x in dollars is given by C of x is equal to $19.99 plus 0.3x, where x is the number of miles she drives. We are to find the inverse function of C of x. So, how do we get started? We start with our function C of x is equal to 19.99 plus 0.3x. We replace our C of x with y. Then we swap our x and our y's. So in the place of our y, we're going to write x. And in the place of our x, we're going to write y. Now we solve for y. So we can do that by subtracting 19.99 from both sides of the equal sign. And that's going to leave us with x minus 19.99 is equal to 0.3y. To isolate our variable y, we are going to divide both sides of the equal sign by 0.3. And let's go ahead and leave this expression as is. So we're going to be left with x minus 19.99 over 0.3 is equal to 0.3 over 0.3 times y, which is 1 times y, which is simply y. So this here is our inverse function. And now finally we can replace our y with c to the power of negative 1 x, right? Or the inverse of c of x. So let's do that. X minus 19.99 over 0.3 is equal to c negative 1 x. I'm going to put a box around that as our inverse function. Now the question is what do x and the inverse of c of x represent in the context of the inverse function? Well, what we are doing is we're taking this function here and we're replacing the x-axis with the y-axis and the y-axis with the x-axis. So to understand what x represents, we need to go back to the original function and see what is the x-axis, what is our y-axis. So in this case, our x-axis is horizontal and our x is the number of miles she drives. So I'm going to put here miles for my x-axis. And what is our y-axis? That is c of x, and that's the total cost. So I'm going to put cost here on my y-axis. Now when we find the inverse function, what we're doing is we're swapping and we're flipping the axes. So now our horizontal axis is our cost and our vertical axis is our miles. So let me go ahead and draw that over here on the side. We have our x-axis, which is no longer miles. It is now cost. We have our vertical axis, which is no longer cost, but it is now miles. So what does x represent? X is our horizontal axis. X represents the total cost. Now the question is what does the inverse of c of x represent? Inverse of c of x is our y-axis, and our y-axis is miles. So let's put here the total number of miles driven. Part C asks us, how many miles did Peggy drive if her total cost was $34.99? Well, let's go ahead and use our inverse function. X is our total cost. So in this case, our total cost is our x. And they're saying, what if our x is $34.99? What is going to be our total number of miles driven? This is our c, the inverse of c of x. Right? So let's go ahead and plug in to our equation and find out what is the inverse of c of x if our x is $34.99. So here we have substituted 34.99 for x, and we're given this equation. Let's go ahead and simplify a bit, and we're going to get, in our numerator, we're going to get 15 over 0.3, and let's do that division, and that's going to equal to 50. And 50 what? Well, what is the inverse of c of x? It is the miles. It is the y-axis, right? It is the miles that Peggy has driven. So here, what is our units on 50? It is 50 miles that she has driven if her total cost is $34.99.